Alright, so the lesson today is teaching you how to sketch parabolas in the turning point form. As previously, we've learned how to plot parabolas in lesson 1, and Mr. Ballas taught you guys how to sketch simple parabolas and about the reflection, the dilation, the translation of the parabolas. So in this lesson, we're going to learn how to sketch parabolas in the turning point form. This one is much easier if you can change or rearrange the quadratic relationship to the turning point form, and it helps you to sketch the parabola much easier. So first, absolutely, we have to learn what is turning point form. All right. So if the standard formula of a parabola is y equal ax squared plus bx plus c, then the turning point form gonna be a bracket x take away h squared plus k. Okay, so this one is the standard form, and if this one and this one exactly, for example, it may be the same, they are the same parabolas, but in two different forms. We're gonna do some example and you will see. So every parabola has the turning point. This one when you look at this one, you can identify straight away the turning point of the parabolas. However, when you see the standard form, you cannot identify the turning point. Okay, so it's the difference between the turning point form and the standard form. Now, so if you have the standard form, the parabolas or the relationship is in this form, then A here, the coefficient in front of this one, is the reflection or the dilates of the parabolas. For example, if A is bigger than 1, then your parabola is narrower. If A is smaller than 1, your parabola is wider. And this one is the translation of the x-axis to the left or to the right. This one is the translation in the y-axis, up or down. All right, and the square here is because the parabola is in the quadratic form. Parabola is the quadratic relationship, so this one needs to be square, in the square form. Okay, so once you have this form, then look at this one, you straight away pointing out the turning point. The coordinate of the turning point is h and k. The coordinate of the turning point is h, k. The axis of the symmetry, which is the line that divides the parabola in exactly two parts, is x equal h, which is this one. All right, so be noticed here, this one is negative h, but the turning point, the coordinate of the turning point is h only, and k. This one have to be negative, this one have to be positive. And the axis of the symmetry is x equal h. And our x-intercept are calculated by solving this equation equals 0. Because x-intercept when y equals 0. So what you do, you just substitute 0 into here and solve this equation to find the x-intercept. Alright, let's check it out how to find the turning point with some example. So, first, find the turning points and the axis of symmetry of the following quadratic relationships. The first one is this one. So there's nothing to deal with the coefficient in front of the quadratic form. This one, it just tells you that the dilation of the parabolas compared to y, the basic one, y equal x squared. All right. If this one is the basic one, then if this one, the coefficient in front of x squared is bigger than 1, then your parabola is narrower or skinner. If this one is smaller than 1, then your parabola is wider compared to this one, compared to the basic one. That's it. All right. So from here, we're going to use the formula here. To point out the turning point. So in here, I'm going to have this one is A, x take away h. This one is k. So my turning point is, the coordinate of the turning point, TP, is 3, 5. All right, h bigger h is 3 and k is 5. So the coordinates of the turning point is h, k, which is 3, 5 in here. And the axis of the symmetry is x equal h. So the axis of the symmetry is x equal 3 in this question. Move on to the next question. Y equals, so it means 1 here, x plus 1/2 square plus 3. So what is the turning point? All right, your different color. So this one is a equal 1, x plus 1/2. It means x take away negative 1/2. All right, because in the form here, the original form, this one have to be negative. Okay, so this one is positive. Then I have to change to take away 1/2, take away negative 1/2. So it means your h is negative 1/2 and k is 3. So the turning point here is, the coordinates of the turning points is negative 1/2 and 3. And the axis of the symmetry is x equal negative 1/2. Okay. Next question, question 3. Again, in this question, we can see here a equal 1. All right. So you check it out. A equal 1. H, it is negative already in here. Is it negative? So we leave it like that. H gonna equal with 7. And K, because this one have to be plus, so we change it to plus negative 4.5. So K equal negative 4.5. So the turning point gonna be 7, negative 4.5. And the axis of the symmetry is x equals 7. All right, move on to this question. Question 4. I have y equal x squared plus 4x, take away 5. I have to change it to the turning point form in order to stay away the turning point without sketching, the turning point and axis of symmetry without sketching. So with this one, we've learned in the previous topic, if we have this one, we have to complete the square to bring it to the turning point form. All right, so let's check it out. Y equal x squared plus 4x, take away 5. Now we do this one first. X squared plus 4x, take away 5. We have to change it to something square plus something here. Okay, so it means that we have to bring this one to a complete square, a perfect square, and plus something. All right, so I see that x squared here, I can split this equation to, I'll do it here. X squared, a squared, plus 4x plus 4, and then number 5 here, I split it into plus 4 and take away 9. So can you see here? Plus 4 and take away 9 equal negative 5. And 4x here, x squared here, x squared here. They're exactly the same two equations. However, when I group these three together, what do I have? Perfect square. X plus 2 square and take away 9. So this equation, this expression has turned to this expression. Then I can write down my final equation of the relationship is y equals x plus 2 square, take away 9. And from here, easily I can state the turning point coordinates are negative 2 and negative 9, right? Why? Because this one is a equal 1, and this one is x, take away negative 2, so h equal negative 2, and this one is take away plus negative 9, gonna turn to plus negative 9. So it means plus k, so this one is k. Okay, so that's why I have the turning point is negative 2 and negative 9, the coordinates of the turning points. And then the axis of symmetry is x equal h, which is x equal negative 2. Done. Now move on to example 2. We're going to sketch these parabolas in the Cartesian plane, not using the table of values. We're going to use the turning point form. Okay. So now first, when I see this one, they ask me to state the coordinate of the turning point. So this one easy. Is going to be, the turning point going to be negative 2 and negative 1. You can see here This one, a is 1, and a is 1, and then x, take away -2 square. So this one is h, and then take away a plus -1. This one is k. So that's why the turning point is -2, -1. Whether this one is the maximum or the minimum, okay? Remember the previous email that Mr. Bowers taught you guys that if the number in front of the x square here is a positive number, then you're gonna have the shape of the data. Or in the first video, I taught you already. This one, the shape of the parabola is gonna be concave up, where we're gonna have a minimum turning point. So this one is the minimum turning point easily. Because why? Because the value in front, the coefficient in front of x squared is positive. Okay? When you expand this one, it's gonna turn to like this: y equal x squared plus 4x plus 4, take away 1. Okay? So it means that the coefficient in front of x here is 1. In front of x squared is 1. And if the coefficient in front of x squared is positive, then you're going to have a minimum turning point. And then now sketch the graphs using turning point form. So you have the turning point is -2, -1. What you do here, you're going to plot that point into this one. So -2, -1, -2, and -1 here. So this one going to be your turning point. And the parabola is going to have this shape. So it can be this shape, okay? It can be like that. We have to identify if it's this shape, then it means that it's going to cut the x-axis at 2 points. So we have to find the x-axis here and the y-axis, okay? So we're going to find x-intercept. To find x-intercept, we just substitute y equals 0 in here to find the value of x. So we're going to use different color. So it is x plus 2 square, take away 1, equals 0. And then we move 1 to the other side. X plus 2 equal 1 square. All right? And then we get square root in both sides of equation. Then we're going to have, do I have enough space? So we're going to have x plus 2 equal plus and minus 1. So your result is x equal, so I'll just write here. So x plus 2 equal 1 or x plus 2 equal -1. Then your answer going to be x with this one. X plus 2 equal 1. Then you move 2 into here. X equal -1. And this one is x equal -3. Okay. So we have 3 points, 2 points, 2 x-intercept. X equal -1 and x equal -3 here. And -3 here. Okay, 1, 2, 3. We have 3 points already. Now we have to identify the y-intercept because your shape, look, your shape can be like this. Okay, or your shape, maybe your shape can be like this. So we have to identify whether we have the y-intercept or not. All right, so y-intercept when x equals 0. So we substitute x equals 0, y going to equal with 0 plus 2 square, take away 1. So it's equal 4, take away 1 is 3. See? So y-intercept when x equals 0 is 3. So it's 0, 3. X equals 0, y equals 3. 1, 2, 3 here. Okay. Then you connect them all together. I just draw because you know that the axis of symmetry is going to go through the turning point, which is this one. So we just draw the turning point, the axis of symmetry here. Okay. And the axis of symmetry will divide the parabola into exactly 2 parts. So you can use the reflection to find another point in this one. So from here, the distance from here to here have to equal with the distance from here to here. So the next point is here. Okay. You don't have to use this point. You can use only 4 points. 1, 2, 3, 4. You can finish the parabolas already. But I just want to make a good shape, or I just want to remind you about the axis of symmetry. So axis of symmetry divide the parabola in exactly 2 parts. So it means the distance from here to here equal with the distance from here to here. You can see easily. Therefore, the distance from here to here has to be equal with the distance from here to here. So you're turning your parabola now is like this. Done. Okay, and then you write down the equation of the parabolas. Y equals, next to the parabolas, y equals x plus 2 square, take away 1. There you go, then you're done. All right, this one is x, this one is y. You don't have to make a table of values